Alrighty, let's go ahead and take care of this homework. What was it that Thomson discovered about the atom?
There's negatively charged particles.
That there were what about them?
And a positively charged nucleus.
No.
But it's wrong.
Negatively charged particles that can come off. So he found that there was a particle that could come off of the atom, and they called that, they decided to say that that was negatively charged, which meant that the rest of the atom couldn't come apart and that it was positively charged. How did he know that it had to be positively charged? So if the electrons came off and they were negative, and the thing that you had before the electrons came off had no charge, how could that be? I got something that's not charged and a charged particle comes off. The thing that's left behind has to have the opposite charge so they cancel each other out. So that's what he discovered. Nothing about nucleus or any of that stuff, just that there's things that are positive and things that are negative, and the negative thing can come off of the atom. All that stuff about the plum pudding, that turned out not to be true. But the things that were true is what we have here. And what about Rutherford? What did he do?
Was he the guy with the cathode ray?
No, that was Thomson.
Oh.
What did Rutherford do?
He did the gold foil experiment.
He did the gold foil experiment, and so from the gold foil experiment, what information did they learn?
So there was a very small positive.
That the positive that Thomson had figured out is very tiny and dense, and so they he figured out that all of that positiveness was collapsed down into a tiny, tiny center that is very, very dense. They already knew it had to be positive because they already knew the electrons were negative. What was Sadi's contribution?
Yeah, the scales, right?
Nope.
The positive was
Yeah, Sadi figured out the nucleus is composed that there are tiny positive particles called protons in the nucleus. So a nucleus that is larger than another nucleus isn't just a larger positive thing, it's more positive things of the same size. So if hydrogen has one positive thing, helium doesn't have a positive thing twice as big and twice as charged, it's got two little positive things. And he named those things protons. How about Chadwick?
Was he the guy with the electron?
No. Found the neutrons. Bohr's contribution?
The
orbiting electron here.
He came up with the solar system looking model of the position of the electrons, which is okay to think about in some respects, but in a lot of ways it's incorrect. And how about Heisenberg?
found that the orbits aren't exactly
They
the
don't
same.
Yeah, they don't look like the elliptical orbits of a solar system.
Yeah.
So he, let's say, determined where the electrons are going to be located based off of math, some really hard math.
Would it be correct to say they use the quantum mechanics to find them?
He,
Or figure that out?
there was no such thing as quantum mechanics yet. These guys were developing quantum mechanics. So quantum mechanics actually is this. It's a chicken and the egg kind of thing. It's like they didn't use quantum mechanics to discover this. They created quantum mechanics in discovering this. But this is, you're correct, it's based off of quantum mechanics stuff for sure. Okay, so when you get right down to it, when you're measuring the temperature of a substance, you are measuring the what of the substance molecules? Speed.
Oh.
In kinetic energy, there's two parts, mass and temperature. You're not necessarily measuring the mass so much, but you definitely, if I put a thermometer in myself and it reads 98.6, and then I do it again later on when I'm not feeling well and it reads 101, did my mass change?
No.
No. But the speed of my molecules, those things are moving around faster. So that's really, I measure something's temperature, what you should be thinking about is stuff flying around, vibrating in place, moving around faster. I put a thermometer in a pot of water and it says 60 degrees Fahrenheit. I take it up to boiling. Just think about those molecules of water flying around inside that pot, hitting that thermometer harder. So we're really just talking about speed. How about the isotope? What's that one? With the set number what? Okay, yeah. Do I have to say set number of protons? No, because the proton number is set for any atom. So if I'm looking at nitrogen, okay, great. Nitrogens have 7 protons, period. And most nitrogens have 7 neutrons, but some have 8, some have 6. So we're talking about one of those particular nitrogens with this number of neutrons, or any of the other elements with this number of neutrons. Allotrope?
That's when they're connected in different ways with itself.
Well said. So I'm taking an element and I'm connecting it to itself, and then I'm taking an element and connecting it to itself differently, and taking an element and connecting itself to itself differently. So I give you a bucket full of red Legos and say build something. That's an allotrope of Legos, red Legos, let's say, and then you disassemble it and you put them back together a different way. That's another form of these red Legos and another allotrope. So it's just those elements has many ways that I can hook them up together. And how about the diatomic answer?
Something combining with itself.
Yeah, isn't it 2 elements combining?
How did you want us to list?
You could. 7 elements that form so just a 2-atom molecule, it's forming with itself. So then there are only 7 of them.
And they can connect more than twice with themselves?
We don't care.
We don't care.
We just care that there are 2 of them.
Okay.
They can hook up to themselves however they want as long as there's only 2 of them. So 2 H's or 2 N's or 2 O's, 2 F's, 2 Cl's, 2 Br's, 2 I's, and then they'll connect to each other in some way, but there's only 2 of them. How about this 33-year thing? Two things. It's not charged and no one was looking. Okay, so beryllium. We find beryllium on the periodic table, and we see that its element is, or it's in position number 4. So that's its atomic number is number 4. If its atomic number is number 4, that means 4 protons. So that means 4 electrons. Its mass is 10, and then this is beryllium. Um, 82. If I've got 82 protons, I have 82 electrons. If I have 82 protons and 207 is my total mass, then I've got a number of neutrons equal to 100 and, what'd you say? 120. Yeah, 125 looks good. And number 82 is which one? Okay. OS? What's the name for OS? Osmium? Does anybody know what the interesting point of the element osmium is?
Sounds like a transformer.
I didn't hear that.
I don't actually know.
No? I didn't.
I said it sounds like a transformer.
Oh, osmium. Yeah, that's a pretty good name. It's the most dense element. We would make bullets out of it, but it's expensive and there's not a lot of it, so we don't. But it would make sense to make bullets out of it, right? One object that's more dense than another object goes through that object. All right, so osmium. If I'm named osmium, how many protons do I have? 76? So that means I also have 76 electrons. And so then my atomic, or if this isotope has a mass of 190, then I've got 14. That looks good. 114 for my neutron number. Okay. If my name is radium, then I have a symbol of Ra, and I've got an atomic number of 88, which gives me 88 protons. And if I've got 88 protons and 138 neutrons, I've got something 226, is that right? 226 for my total mass. Okay. Periodic table shape, what's that based off of?
What page?
Say again?
So we can on one page.
Okay. How about the rest of it?
The rows react with each other, or react similarly. What's the?
How about columns,
That's
not
good.
rows? Yeah.
Yeah.
So the columns have similar.
It's a hard word.
What's the other answer to this question that's not correct that people want to say?
The rising of
No. That's part of it. Sure, it's rising in atomic number, but it's also, it's really about the columns. People will say something about reactions of electrons. Now, the elements do chemically react similarly to each other in columns because they have the same sort of electron configuration. But the table itself was not created by a person who even believed in electrons. So the table itself came from observation of similar chemical reactivity. That chemical reactivity is based off of electrons, but that's beside the point. It was an afterward thing, right? I didn't figure out electrons and then make a table, because if we knew what we know about electrons now, that periodic table would be made in like 10 seconds. But we didn't know anything about the electrons, so it was all based off of chemical reactivity.
So my answer came from your notes directly, and it says the shape of the table is based on the arrangement of the electrons.
That is worded poorly. Worded poorly. The reason the table has the shape is based off of its electrons, but the table shape was created because of similar chemical reactivity. So thanks, I'll reword that.
So the other part, the rows, the elements in the rows react differently the further apart they are from each other.
You could say that. That's a result of these column things for sure. Energy levels? How many of those we got? 7 energy levels. How does that relate to the periodic table?
There's 7. One for each
Rows.
Yeah.
7 rows. Sublevels? 7. Why are there 7 sublevels? This isn't the question, but why are there 7 sublevels? Each energy level has its number of sublevels, so if there's an energy level number 7, that means there are 7 sublevels in energy level 7. It's the only energy level that has 7 sublevels, but there are 7 possible sublevels. So they're S, P, D, F, and then G, H, and I.
Some people die for gold.
Okay. And I put that in the wrong spot. And which ones don't we so much care about? G, H, and I are not super important because we don't have that many we don't have atoms that have so many electrons that we regularly fill G, H, or I. But does that mean G, H, and I positions don't exist? They do. It's like having a large apartment complex with no elevator and the top floors are there. It's just nobody lives in that. You can totally go up to them if you want and hang out there for a little while, but you're not going to live up there because it's too far away from the ground. Electrons, how many electrons fit in an orbital? 2, that's it, just 2. So which sublevels are found in energy level 2 and how come?
The 3 Ps, that part of it,
Well, okay, those are orbitals though.
Oh.
So the S sublevel and the P sublevel. The S sublevel is found in every single energy level. The P sublevel is found in all the energy levels except which? Number 1, because it can only have 1 sublevel. Okay. So it's 2 sublevels, S and P are found in there because it's energy level 2, so it has 2 sublevels. How many electrons fit in the 4th energy level and how come? So sublevels? Okay. And how many orbitals are in S? Orbitals. Orbitals. 1. How many electrons fit in an orbital? 2. So there's 2 electrons in that S. We good with that? So how many orbitals are in a P?
6.
Orbitals.
Oh, 3.
3. So this just goes up by odd numbers, right? 1, 3, 5, 7, and keeps going. So 3 orbitals here, which leads us to 6 total electrons. 5 orbitals in D, which gives us 10 electrons. 7 orbitals in F, which gives us 14 electrons. And if we add them all up, what do we get? 32 total electrons can fit in that 4th energy level. Okay. That looks good.